Hello, this is John Schaap and welcome to this video in the updated 2021 version of the AOS 8 video series. In this video we are going to have a look at implementing and configuring a 3-node controller cluster and adding 3 access points and an employee Wi-Fi network using 802.1x, RADIUS and Change of Authorization. For the Change of Authorization to work, we need to configure VRP on the cluster members. You see here that every cluster, so VMC 1, 2 and 3, has a physical IP address. That's 202.31.32 and 33 for VMC 1, 2 and 3, but also a VRP IP address, and that's 131 for VMC 1, 132 for 2 and 133 for VMC 3. This address will be used in the RADIUS IATF NES IP address field that is sent to the ClearPass server, so that the server knows where to send the CoA message back to, because that's initiated from the ClearPass server. If you do that to the physical IP address and the node goes down, then the message will not be delivered. And by using VRP, you make sure that the message is always delivered to the right node where the client can be found. Here you see an access tracker record from ClearPass, and you see that NES IP address is set to the VRP IP address that is configured on the virtual mobility controller. And I will show you later on how to do that. And this is then a successful RADIUS CoA action where a client is being bounced off the Wi-Fi network. Last time we have added 3 virtual mobility controllers to the MCR, but they are not yet in a cluster, as you can see here, because it says 0 clusters. So first of all, I want to discuss configuration hierarchy, and after that we're going to add the cluster to the system. So if you look on the left hand side, you see here mobility conductor and 2 mobility conductors, number 1 and number 2. And there's a thin line here, and that's where managed network starts below. So that means that if I configure something here on mobility conductor, so if I go to mobility conductor and then in configuration and change something here, it goes down to the 2 mobility conductors, but it stops at this line. The next hierarchy starts here at managed network. That folder is always there, and you should leave that there, not touch it, and start with your root folder beneath that. In this case, I created a folder called HPE. And then underneath HPE, I created 3 territories: APJ, EMEA, and US. So the config hierarchy works as follows. If you configure something here, so if you highlight it, that it becomes orange in the HPE, that means that everything that you configure here will flow down to the lower hierarchy. So to APJ, to EMEA, to the 3 controllers, and to the US. If you configure something here, it only goes down to the 3 controllers that you find below there. And if you configure it down here, it's only on this virtual mobility controller. So let's first go to this folder and create an AP group in here. So we go to AP group and we say, okay, I want a global AP group. If I click submit, pending changes, you'll see which controllers it's going to install it on 3 controllers, all 3, VMCs 1, 2 and 3. Say deploy changes, and it's there. So you see now that we have global AP group here, but also there, there, and there. So if I configure something here, let's say an EMEA AP group, and deploy that, then you see again that it's being deployed on all 3 controllers. So we now have global and EMEA here, 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 and there, but not in the US or APJ, because that is not below EMEA. So that is how config hierarchy works. And what you configured at a higher level can be overwritten at a lower level. There are some exceptions, which I will show you here. Now there's 5 things that cannot be overwritten at the lower level, and those are shown here. Net destination, IP access list, user role, AAA server group, and AAA user derivation. Okay, and then we continue with some other things that we need to enable. So we go to this folder and we go to System, nope, Services, Firewall, and I want to enable firewall visibility and deep packet inspection for everything. So that's why I configured it here. Deploy it. And then the next thing is we're going to create a cluster. So the cluster is going to be created in here, because this is a cluster in EMEA, so that's why I configured it at this level. You go to clusters, click plus, give it a name, and then the first one is this one. Just give it a group number, number 1. And also the VRP address is important. This is only needed if you want to send RADIUS CoA messages back to the controller from your RADIUS server. If that's not the case, then you don't need to configure this, then you can just leave it like that. But in this case, I want to send CoA messages from the RADIUS server to the controller. And to do that, we need to configure 3 VRP groups on these 3 controllers. So in this case, I'm going to use the same subnet 202, but I then use 131 for the first one. It's in VLAN 202. Wrap public IP, multicast, and priority we don't need. So that's 1. Number 2, 32. Same group, of course. 10, 10, 202. 132. Same VLAN. And number 3. The last one, same group. 10, 10, 202, 133. And the same VLAN. And it will create VRP IDs automatically. It starts normally at 220 until 254. That's the reserved IDs for COAs. But you can also modify that. So I say I want to start at 250. And I also need to configure a passphrase for VRP. And then we click submit. So now the cluster is configured. And then the next thing you need to do is go to the individual controllers and say if they are a member of a cluster, yes or no. And in my case, all 3 controllers will be based on this cluster. So I put them all in the EMEA cluster. Number 1, number 2, and number 3. Submit. Okay, I'm going to deploy it. And now your cluster is going to be built. That can take a couple of minutes. The cluster is up and running. And you can see that we now have 1 cluster with 3 controllers in there. There's no load yet. There's no APs connected and no clients. So you don't see anything here. And you can exactly see how many access points can be connected to this cluster and how many clients can be connected to the cluster. That all depends on the type and version of machines that you have in your cluster. So I have 3 VMCs, but these are the smallest ones for 10 APs each. So it's 30 APs in total. That you can see here. So 10, 10, and 10. And 256 users per device. Let's have a look at the command line interface, and that shows you what VRP, what this cluster has built on VRP. So if I do show VRP on VMC 01, you see that it created an instance 250, 251 and 252. And it did that on all three cluster members. And this one is master for 250. The next one is master for 251. And the last one is master for 252. The other thing that you can do here is show LC cluster group membership. That tells you how the cluster is looking, if it's okay or not. Because a cluster can be layer 2 connected or layer 3 connected. And it needs to be layer 2 connected if you want to have seamless failover between the cluster members. And it's only layer 2 connected if all the VLANs that you use are configured on all controllers and also on the infrastructure in between. So if I have VLAN 100 on VMC 1 and VLAN 100 on VMC 2 and on VMC 3, the switch in between also needs to transport that VLAN. So it needs to be on all the controllers. Here you can also see how the cluster is handling client load balancing and also AP load balancing, what the thresholds are for that. So this is important, L2 connected, that needs to be checked. And then you're good to go, and then you have seamless failover between the cluster members. So the next thing that we're going to do is add a VLAN. So we go to configuration and go to interfaces, VLAN, and add VLAN 202 to 02. Okay. And we need another VRP group because when an access point boots up for the first time, it needs to connect to one of the mobility controllers. So an access point will never talk to a mobility conductor, and it never needs to connect to the mobility conductors over here. It only talks to this one, or this one. And when it initially connects for the first time to that cluster member, the cluster member then tells the access point, you are connected to a cluster, or you are going to connect to a cluster, and these are the three nodes that we will find in the clusters with the IP addresses. So it gets a list, a so-called node list, on the access point, that's stored on the access point, that it will then use to connect to. You could just say, just put it on an IP address of VMC 01, and then it will always connect to 01 for the first time, and then it will be load shared across the other ones. But if VMC 01 is down for whatever reason, it then will not connect. A new access point will not connect. So that's why I create another VRP group over the three cluster members, and that is the IP address where I let my IPs connect to for the first time. So how do we do that? We go to redundancy, layer 2 redundancy, and we're gonna create a we call it cluster redundancy. And then we're going to use the IP address 10.10.202. And the one that we don't use yet is 30. Needs to be up, and it needs to be in the correct VLAN. Okay, VLAN 202 is the VLAN where all the VMCs have their IP address in. And for the rest, I don't need to do anything. Just submit and get it going. So, and this is then the 10.10.202.30. That's the IP address that every AP initially will connect to, and then it will receive the node list from the cluster members, and then it will never use that address again until you completely factory default it, and then it's time to connect to that address once again. So how does the AP get this IP address? That's done in my case in option 43 on the DHCP server. So you go to server options and you specify option 60 with the string value Aruba AP. And in option 43 you specify the IP address of the VRRP instance of the controller cluster. And that's all you need to do for the AP to discover the controller cluster. You see that the APs have connected to the controller cluster, but they are not active right now. There's one alert, and you see that there's 3 APs unapproved. So you have to approve these APs manually. That's what you do here. Give them a name, put them in the correct AP group that you want. Status is accepted, and approve them. And you have to do that one by one. The reason why I need to do this is because control plane security is on and auto cert provisioning is off at the moment. So that means that you have to manually approve APs that come into the system, new APs. You can either turn control plane security completely off, or you can turn on auto certificate provisioning if you want to avoid having to manually approve all your access points. So APs have been approved and have rebooted and connected again to the controller. And you can see right now that they're all up and running. You can see that they are connected to a cluster. You can click on the cluster and you can further investigate the cluster, and you now see that capacity, the AP load, is taken from the cluster. So the APs are spread across these 3 cluster members evenly. So you have an active and a standby tunnel from every single AP. So that's 3 active and 3 standby tunnels currently used. In the command line interface, if you do show AP database, you can also see that they're in the right AP group and that they are connected to 2 switches, to the active one and the standby one. And that should always be the case in a controller cluster, 1 to the active and 1 to the standby. Now that the access points are up and running, it's time to add our first Wi-Fi network. So we're first going to add a VLAN. Got to give it a name and a VLAN ID. That's 211 in this case. And deploy that. And then we're going to go to tasks, deploy new wireless LAN. Give the wireless LAN a name. And in this case it's an employee wireless LAN, so I leave it to employee. The VLAN is the VLAN that we just configured, the employee VLAN. That's where I want these users to end up in. I'm going to select WPA2 Enterprise. For that you need a RADIUS server. So we are going to add ClearPass as RADIUS server. Let's give it a name, give it the IP address of ClearPass. The shared key, of course, that needs to be configured on ClearPass also, and it needs to be the same, otherwise it will not work. Okay, that's fine. And then we go next. And the default role, that's the role after successful authentication. I'm going to put these users into the default role authenticated. So now that the wireless LAN has been configured, it's now being configured on the cluster members. And if we then go to the command line interface of a mobility controller, and we do show AP BSS table, that will show you if this controller is sending out BSS IDs on a particular AP, and it does it here. You see that employee 89 is broadcasted either on both on 2.4 and on 5 GHz on one AP. So we need to do one more thing. Because we want to send back COA, we have to do dynamic authorization. IP address is the IP address of ClearPass. Okay, and then don't forget to fill in the key here. If the key is not filled in, so you see the dots, but it's not there yet. You have to type it in. That's the same key that you use for RADIUS communication with the RADIUS server. And after this, the RADIUS server is able to disconnect clients from the network. You have to do one more thing. You have to go to the AAA profile that's configured for this wireless LAN, and select the RFC 3576 server that we just configured. Put it in there and save it. And now you're ready to go. So client is connected. You see that the name of the client is employee 1. You can expand that and see more details about the client. Also that it's connected to an active and a standby mobility controller. And if you go to traffic analysis, you see what applications the user is using, what destinations it's going, and which hosts is it visiting. If we go to the command line interface and do show user table on the active controller, you see that we have a session, username employee 1, authenticated role, .NX authentication, and every user also has a standby session, and that is what you see here. Show user table standby on the other controller. This is the controller where the user will go to if the active controller fails. So that session is already there, so there's seamless failover. This is the radius request coming into the radius server. And very important is that you see that NAS IP address, that is the VRP IP address, should be in there. And then you can do a radius CoA. So here I'm going to bounce the port, so disconnect the user, that it connects again. And you should see a successful message if you do this. If it's not successful, then something is not configured properly. And you will see that the user comes back in after the disconnect with a new session here in ClearPass. To recap what we have done in this video, we have built a controller cluster consisting of 3 controllers, each with their own IP address and also with their own virtual IP address. That's 131 for VMC1, 132 for VMC2 and 133 for VMC3. This virtual IP address is used in the NAS IP address that is sent in the radius packet to ClearPass, so that ClearPass knows where to send the CoA packet if it needs to do a CoA action from ClearPass. Besides these 3 virtual IP addresses, there's a 4th one called the cluster VRP 10.10.202.30. This is the IP address where an access point, when it first boots up for the first time in its life, connects to get the node list of the nodes of the cluster. And the node list consists of the physical IP address of the controller cluster member. So that's 31, 32 and 33. And from that moment on, the AP will reboot and will then not connect to the virtual IP address anymore, but will connect to one of the cluster members. To which member it connects to, that's all decided by the cluster leader, which is selected automatically for you. And the cluster leader, it takes care of sharing the load amongst the cluster members and also the user load. So when users connect to the Wi-Fi network, they are also shared across the clusters, because every user also has 2 sessions, one to an active and one to a standby cluster member. The same for the AP, also 2 sessions, one to an active and one to a standby controller. That brings us to the end of this video, so please like, subscribe and let me know in the comments what you think. Bye for now.